Greetings and welcome, Algebrudies. You know what? I told you I'd be here. I told you I'd do some of the homework with you. And here I am, guys. Kept my word. Right? I'm going to Samwise Gamgee take these problems to Mordor with you, all right? I will take it. Here we go. Let's see. This radical was already by itself, so I didn't have to isolate it. To get rid of a cubed root, cube both sides. Boom. And x minus 16 equals 8. Oh, look at that. Add 16, add 16. X equals 24. Now, actually, in the case of cubed roots or odd roots in general, I don't believe they ever have any issues with extraneous solutions. But let's do the check. They asked for it, and we kind of need it. Actually, I wonder what it looks like on the Big Ideas version of this, because I know sometimes the format of these things the problems are given a little bit differently. Let's see. Okay. Oh no, I still wanted blue. 24 minus 16 is 8, and cube root of 8 is 2. True. So that's a legit solution. Boom. That one's not bad. Okay, we got this square root. Let's get that by itself first. So subtract 13 both sides. Negative 2 rad 24x equals a negative 24. You know what? I'm tempted to like simplify the square root of 24 since 4 goes into it, but we can leave it. We don't even care. We're fine. Divide both sides by negative 2. So I'm trying to get this square root by itself as much as I can before I pull my power play. So this is positive 12. Here we go. To get rid of the square root, I square both sides. Inverse operations, friends. Inverse operations. I so should know this. It does go in. Is it 6? It's got to be, right? I'm reaching for a calculator, though. I've been wrong on the internet way too many times. It works. All right, do a check, guys. I'm gonna be with you. I'm doing this. All right, I'm doing it. Negative 2 square root of 24 times 6 plus 13. Is that equal to negative 11? Barely fits. Negative 2 times the square root of 24 times 6. Well, I happen to remember that off the top of my head from 3 seconds ago. Equals negative 11. Negative 2 times 12 plus 13. Is that equal to negative 11? That's negative 24 plus 13. Is that equal to negative 11? Guys, it worked. And so this is a legitimate solution. Good news. All right, here's this is the boss fight. This is the toughest one. The radical's already by itself, so I'm going to square both sides. 44 minus 2x equals, this is the tricky part. Now, you're going to want to take the lazy wrong way out. And isn't that weird that, like, human nature, like, you could know that you're going to be wrong, and it's like, but it's easier being wrong. That's weird. But it matches one of our patterns. Square of a binomial is equal to a squared plus or minus 2ab plus b squared. You got to use it, or you could write x minus 10 times x minus 10 and double distribute your way out of it. But notice, by the way, this is a minus sign, so I'm using the minus version of the pattern. Okay, so I'm going to have a squared minus 2ab plus b squared. A is the x, b is the 10. And let's simplify. So x squared minus 20x plus 100 is equal to 44 minus 2x. Let's double step this. So now that it's a quadratic, I got to set it equal to 0 and solve. So add 2x to both sides, subtract 44, 44. And I get x squared minus 18x plus 56 equals 0. Is this factorable? Factors of 56. Guys, this is the bane of my existence, 56. 25 plus 3. Notice I did 50 divided by 2, and then 6 divided by 2, and then I add them together. 25 plus 3 is 28. Does 3 go in? No, because 5 and 6 don't add to a number divisible by 3. 4 goes into 28. 4 goes into 28 7 times. 7 times 2 is 14. 5 doesn't work. 6, no. 7 goes into 14 twice, and 2 times 4 is 8. Got them all. So do any of these add to be 18? Oh, got them. Nice, nice. Guys, by the end of the next chapter, you'll know how to solve non-factorable quadratics. Good times. In this case, it's going to be minus, minus. They multiply to be positive, add to be negative. Set each to 0. X minus 4 equals 0. X minus 14 equals 0. Solve. I get x equals 4. X equals 14. Now, we can't believe them. They might be wrong. Even though I assume I didn't make a mistake. But even if we do everything right, there's still a chance that they're extraneous. Extra solutions. So 44 minus 2 times x equals x minus 10. I'm going to plug this in twice. So I might as well screenshot. Take my lazy way out. It doesn't actually save me all that much time. I like to pretend it does. Plug in 4 for both x's. Is the square root of 44 minus 8 equal to negative 6? Well, I already know this is not going to work. Is the square root of 36 equal to negative 6? That's a no-go. If this said plus or minus, right? It doesn't, though. It doesn't. So this is extraneous. Extraneous. And, oh, gotta get my sky blue. Let's plug in 14, see if we got any better luck. The fact that this side is going to be positive, that's a better chance of it working out. 44 minus 28, okay. The inside's going to be positive, that's a good chance. 14 minus 10 is 4. 44 minus 28 is, it is 16. And square root of 16 is 4. So that works out wonderfully. Wonderfully. And so this problem had one solution. Now, sometimes both will work, sometimes none will work. But you got to do the check when you're solving radical equations. Look how beautiful this is. This is wonderful. I love these problems. Okay, last example, and I chose the ugly one again. So tell you what, we can rewrite the... Oh, this is nasty. Let's rewrite the half root as a square, or half exponent as a square root. Don't worry, I'll show you a good trick on this one. So you don't have to deal with fractions on this. Oh, man. Okay. Now, yes, I could divide both sides by 2, but I'm going to then end up having to, like, deal with fractions and squaring these fractions stuff. Tell you what, because this is only multiplication, and it's not, like, addition, subtraction, like I had, no, never mind, that one was already isolated. But, like, over here, like, you definitely wanted to get rid of anything that's added or subtracted. But when it's only multiplication, you actually could square it at that point and be careful, because you can distribute exponents over multiplication or division. I'm going to choose to do that to avoid fractions, but I'm going to have to play it careful. 2 squared is 4 times this whole thing squared becomes x plus 11. And it'd be super tempting to just drop those parentheses, but I'm actually going to have to distribute that 4 in a second. All right. Now over here, this matches the pattern. Do I still have that? No, I don't. I was wondering if my paste function still had the pattern. But it is a squared plus 2 times a times b plus b squared. It's further up in the video. X and x for a and 3 for b equals x squared plus 2 times 3 is 6. X plus 3 squared is 9. All right, and now this is a quadratic, and we're going to solve by setting it equal to 0. Double step. Subtract 4x both sides. Subtract 44 both sides. And I get 0 equals x squared minus, nope, plus 2x minus, all right. Is that 35? Negative 30. Yeah, negative 35. All right. See, even Mr. Waddy's unsure of his math skills at some point. It's good to know the things that you got to double check yourself on, right? So let's see. Is this factorable? Factors of 35. Notice, conveniently, all of these have had a equal to 1. So I didn't have to AC method or anything. So at least they're not, like, brutally trying to, like, wreck you. This isn't, like, the Dark Souls version of Algebra 2. Let's see. 1 and 35. 2 doesn't. 3 doesn't. 4 doesn't. 5 does. 5 and 7. Do any of these subtract to be 2? So I'm going to have an x with a 5, x with a 7. They multiply to be negative and add to be positive, so their signs are different. And the bigger of the two has to have the sign here, because positive 7 minus 5 would give me a positive 2. Zero product property. Set each of those factors equal to 0 and solve. Hopefully you guys are starting to get some speed on this. Add 5 to both sides, I get x equals 5. Subtract 7 from both sides, I get x equals negative 7. Now, both could be false. So let's do a check. CK for check. I don't know why when I started abbreviating that. You could probably look back on Waddy Math videos from over the years. See the time when that first happened. I didn't want to write the x, though. I've got to plug in numbers there. So 2 parentheses x plus 11 to the 1/2, is that equal to x plus 3? And I'm going to do my lazy shortcut. Plug in both of these. Here we go. 5. All right. 5 plus 11 is 16. 5 plus 3 is 8. Still to the half root. The square root of 16, that's what a half exponent is. I mean, not a half root. Half exponent is the same as a square root. Square root of 16 is 4. 2 times 4 is 8. So that's true. Let's plug in negative 7. I'm a little worried about this one. Oh yeah, this one's not going to work. Negative 7 plus 3. Oh, no. Maybe. Nope. Maybe. No, I don't think so. Drama. 11 minus 7 is 4. Positive. The square root of 4 is 2. Is that equal to negative 4? No. And so this one is extraneous. And the other one worked. And so that's good news. All right, I think that's all I did. Yeah, that's all I picked for today. Whew, man, guys, this is a tough little unit right here. Careful. Don't worry, I think these are like the most difficult problems that show up on the test. I only have got one. And I'll tell you now, it'll be like this difficult. All right, and I'm going to give you a chance to write all of your algebra out. If you're doing it online because you're social distancing, you'll have your equatio where you'll be able to type out all your math, all of your lines of algebra. I'll be able to check your work and give you partial credit, the credit that you earn, right, and are well deserving of. All right, thanks for watching, Internet friends. Have a great day. Bye-bye.